data tool that speaks to HDFS and does everything like say a distributed application would do. Okay. Key issues. These are the key issues Spark is having with Hadoop. One, as mentioned, Hadoop framework with HDFS and MapReduce is key. So we understand that is key component was one of the initial framework that enabled large-scale distributed computing. MapReduce provides solution for parallelization, distribution, and fault tolerance. I know we can't overemphasize this because one thing Hadoop system works on is process running in parallel, being distributed across nodes, and ability to replicate itself. That's a fault tolerance issue. Also, all problems do not easily fit into 2 steps of MapReduce. The API can be bulky as well. Hence, a number of tools have been added to Hadoop ecosystem for importing and exporting data, for manipulating data. So I want to ask you a question. Which of the application on Hadoop ecosystem is used for data migration or data streaming? Let me say data streaming. Which of the Hadoop Hadoop ecosystem application is used for data streaming? The question is 5 marks. I think we believe in marks. I think we need to go back to school methodology. So that's my question. So which application, which of the Hadoop ecosystem, we've mentioned possible application of the Hadoop ecosystem. We've mentioned you guys have come across Scoop, Zookeeper, Fluke, Scalar, and other applications. So which one of those guys is used for streaming, like data migration? So we know that Pig is used for writing a complex queries that is more efficient than even MapReduce. So we know that Pig Latin writes a more efficient MapReduce job. So, but when we talk about data migration or say data streaming, which of the application is used? Oh yeah.
Hello, sir.
Hi.
Would it be Spark?
See, are you giving me a guesswork?
Sir?
Are you asking me? You're asking me, right?
No, okay, Spark.
Okay, so yours is Spark, right? Okay. Oluwatobi. Is Oluwatobi there?
Yes, sir. Yes, sir.
Okay.
So just connected me now, and it's now telling me that I'm not enabled on.
Sir, could it still be Spark?
Hey, see these people. No, wala. You Marvelous asked me a question. You're asking me a question. Yeah, using question to answer question.
Sir, I think it is Spark.
You are thinking, you don't know. Iyola.
Sure. Hello.
Sir, I'm here. Is it me, Iyola? Just to be sure. I want to be sure.
Daniel.
Okay, yes, sir.
Iyola Daniel, okay.
First, I want to ask, data. When you say data streaming, do you mean ETL? I want to be sure I got what you meant by data streaming very well, clearly first.
Okay. Now, so part of the Hadoop ecosystem, there is one of the tools that is used for ETL. So the ETL from, say, a relational database to Hadoop, and a particular application for data streaming. So tell me any one of the two that you can answer. Is it for the main ETL? Do you know which application do we use for ETL, or which application do we use for data streaming? So there are two different applications, but give me answer to one of them.
Okay, thank you for explaining again for that. Okay, I'm not sure I can remember what Zookeeper and others does. I think it's HBase. HBase is to manage database in the Hadoop. So you can use since the no SQL is a no SQL database, you can actually take from structured and unstructured together. I think I use that for ETL. For data streaming, I'm not sure yet, sir.
Okay, that's fine. Sunday.
Yes, sir.
So
for the ETL, I think for the ETL operations, I would say I is the best for using for ETL.
Ebube, what's your own answer?
Hello, sir.
Hi.
Sir, I'm okay. I know when you were mentioning you said the zookeeper. You mentioned we've not gotten to all those aspects. I don't know. So I'll probably
Okay.
for what's the name? What's the first question you asked for data streaming? Yes, I'll go with Spark too.
Wait, so you are telling me you've not done it, right?
Yeah,
So you are okay.
I myself have not done it.
That's fine. That's fine. So I guess maybe you brought your own curriculum from your house.
Okay, I don't think I've not read to that point. Maybe by chance you get
Okay.
so, but yeah, thank you.
No,
So I said
thank you.
Spark for data stream.
You said Spark for data streaming. Adedeji, Adetoro.
Yes, sir. Good afternoon, sir.
Afternoon, ma.
Sorry, sir, Mr. Edward.
Yes.
Is it ETL or streaming? Which one?
The two. If you know for ETL, tell me. If you know for streaming, tell me. Anyone you know.
Okay, I said okay. Okay, I said ETL. My own ETL is I. That's what I said actually. Okay.
Okay, that's fine. I've gotten you. Oh yeah.
Start for streaming. I think I go with Spark too.
You go with Spark too. Richard.
For ETL, I'll go for I, and for streaming, I'll go for Flume.
For streaming, you go for Flume, right?
Yes.
And for which one?
ETL, I.
Hive, okay. Ibitamino.
For ETL, Hive or P. Then for streaming.
I don't understand now. For ETL, what do you go for?
Hive or P.
Hive or Flume?
Or P.
Hive or Pig, okay.
Then for streaming, Spark.
Okay. Thank you. Albert.
Mr. Edward.
Yes, sir.
My Hadoop ecosystem in my brain just booted very well now. I want to
You exhausted your lifeline now.
No, I've said ETL. It's for the streaming I'm talking about now. I've not said anything about it.
Don't worry. Just you've exhausted your lifeline. No, you exhausted your lifeline. Albert. Is Albert there? Okay. So that's fine. So you guys tried. You guys tried. So I know sometimes it is only when we see questions that's when we put our mind to things. So I understand that it's maybe technically true that we put our mind to things we know, we are learning when we have questions around it. So that's why you see that in the curriculum at the end of maybe every session or probably a particular modules, you see questions. So the essence of those questions is to give us grounded knowledge so that you can be sure that, okay, I know this thing. So that's fine. Okay, so you guys should go to page 70. Page 70 of your material. Are we there?
Yes, sir.
Okay. So let somebody read out what we have for scoop.
Scoop,
Yes.
in bracket SQL to Hadoop, is a tool that offers the capability to extract data from non-Hadoop data stores, transfer the data into a form usable by Hadoop, and then load the data into HDFS. This process is called ETL.
Thank you. So I guess maybe some of you guys skip that page, but I think is this something that was telling me that they've not that maybe we've not gotten there.
No, Ebube.
Is Ebube okay? So you see that we've gotten there. So please and please, it is. Let's understand. If I wish I can see you guys physically. There are some of you deserve maybe two punches each. But on a lighter note, we need to understand those basic things. So because if you don't understand what these applications are doing, then when I come to class to just keep talking, it will just be as if I'm reading novel and it's not making sense.
So I have something to say.
All right.
Yeah, because I actually wrote it down here, whereby I was saying, okay, just to be sure of what you are saying, because if that is cool, because I have Flume here. They said Flume is a popular system for moving large quantities of streaming data into HDFS.
Yes, so Flume is for data, is for streaming data, where Scoop is for ETL.
Okay.
So yes, so you use Scoop for ETL and Flume for data migration, and that is streaming. So when you read the description for Flume, it's got that example are like weblog servers, whereby you are having massive inflows of information and you just want to push it into your Hadoop environment. Use Flume. Okay.
Hello, sir.
Yes.
Still on that, because according to the manual here, we have it was also stated that pig also is used for streaming data.
Yes.
And normally, actually, the reason why I went for Spark initially was because we already established that it's used for in memory. So I thought that's okay. That's in memory. That means and we already established that since it is in memory, that means it has low latency, which means it is faster. So my thought was that something that is very fast should support, live streaming and streaming data. Now you said it is Flume, quite all right. But then we also have here that Pig Latin also supports streaming data. So I don't know. Can you?
Okay. So now one of them is application, the other one is language. So it's an application, whereas Pig Latin is just a language, a Java language, a language. Scala is a language. But when you talk about application, the application, so when you're working with application, you don't need to write any language. So it's just like, it's just going to, I don't know if you guys have seen what they call SSIS, SQL Server Integration Service.
Yes,
It's
sir.
an
I have.
So like your Visual Studio is an application. Though on that application, you write your C# on it. So there are two different things. So you use SSIS for ETL, whereas inside SSIS, you can write your C#. So there are two different things. Application is different from language. So don't mix them for each other. Okay.
Okay, sir.
So,
Hello?
Hi, any question?
Yes, I do. Okay, what about the possibility of us using Spark? Because just like I said, I felt that because it is in memory and it has low latency, it should be able to, be used for live streaming or to be used for streaming of data. So is it that we can't use it at all, or Flume is better preferred to using Spark? Did you get my question, sir?
I get it. You can't compare the two. They are independent. Can you compare? I want to see two. I said one is application, one is program. Though both of them work in hand. Are you getting me? So when you, the question I asked was, in the Hadoop ecosystem, which of the application? So I never thought about programming language, but Scala or Spark methodology also works for data, say, migration. It will also do the work of data migration. But in terms of when we talk about application, the go-to-go guy is Flume. So though we can write Spark application, Spark query inside Flume. Are you getting me? But the guy that coordinate that will even enable you to write it is Flume. Okay. So that's that. Please and please, let's just do a little background research on all these things. They are simpler than what we think. Yeah. Okay.
Yes, sir.
Let me share my screen.
Hello, sir. Can you hear me?
I can.
Yeah, I have a question. So what about Spark? Is Spark a language or an application? Because I can't find Spark in the book here too. So I don't want to know if it's an application and what exactly is the function per se. This is not what you are saying.
Okay. So do you see in the book you can't find pig too?
No, there's pig. There's pig. I can't find Spark.
Okay, we have Pig Latin, we have Scoop, we have Zookeeper, we have Flume, we have Ozi, but we can't find Spark. So the question is Spark also an application? Yes. So let me
function. Okay, yeah, just
okay. So now the question is, what exactly does it do? right? Hello.
Yes, that's what I'm asking.
Okay, now, can you see my screen? It said Apache Spark model is an in-memory execution model which allows caching of job data in memory instead of fetching it from disk. I'm trying to see a way to justify how Spark works. As oh, okay. Spark is like an application. The program that runs inside Spark is called Scalar. The methodology that Spark runs on is called in-memory methodology. So Spark is like an application that runs Scalar. So you discover that when we are before previous slide, we said on the presentation, they mentioned different kind of programming language that we can run inside Spark. So what makes Spark unique is the methodology that Spark sits on. What makes MapReduce unique is the methodology of MapReduce, ability to distribute itself. But what makes Spark application unique in its own way is the methodology of in-memory. MapReduce doesn't work with in-memory, but MapReduce works with distributed framework. But Spark is an application that works on in-memory architecture, and it works on in-memory architecture and also distributed computing. So Spark can run programs like Scala, Java, Python. Are you getting me? So what makes Spark unique is its methodology. I'm trying to see how to give you a more visual knowledge. Okay, let's see this. Spark runs on a single platform, highly accessible, offer APIs in Python, Java, Scala, and SQL. So you see that Spark is like an in-memory application that can take in different programming languages. When we get to practical class, we'll see more about these guys. But I don't know how to give you the best visuals about Spark. So let's give me 1 minute. Let's browse something about Spark. Are you seeing my screen?
You can see.
Okay. So that we can read outside our material. Okay. Why? So we are reading this part that defines Spark for us. Spark is a lightning fast cluster computing technology. designed for fast computation. It is based on Adobe MapReduce and it is extend MapReduce model efficiently. It is for more type of computation, which includes interactive queries, streaming processes. The main features of Spark is in-memory cluster computing. They're increasing the processing speed of an application. Spark is designed to cover a wide range of workloads such as batch application, iterative algorithm, interactive queries, and streaming. So now, invariably now, Flume will be sitting on Spark architecture. Because if we know Flume is mainly for streaming, so the underground technology behind, so to me now, I think it will be good for us to conclude that Spark is not an application, it's a technology. And because of the in-memory methodology of that technology, that is what makes it super fast. So that implies Flume must sit on Spark, as we know that Pig Latin optimizes MapReduce. Likewise, Flume is optimizing Spark. So the methodology for Flume will be, or the underlying technology for Flume will be Spark. It might look, so we'll get it with time and we'll understand this, guys, with time. So let's move on. I won't spend a lot of time talking about Spark. Okay. So the performance says, in case of Hadoop, you would need to store the result of each phase of program on disk and have the next phase read results, blah, blah, blah. Okay. Advantage of Spark. We know that one of the advantage of this guy, Pig Latin, is all these applications are easy to use. So Spark API is simpler to use than the MapReduce API. To implement the classic word count example from MapReduce job, you need 3 classes: the main class, the mapper, and the reducer. Okay, let's see something interesting. Spark okay, I'm coming. So another advantage of Spark is unifying platform. Spark combines a number of functionalities of tools available as part of the Hadoop ecosystem in a single framework. Is any one of us having, are we on our system?
Yes, sir.
Yes, sir. Okay. I would like us to see the Spark application so that we can explain few things. Oh, it's a bit complex. No, so don't worry. I wish I'm prepared for a practical class. Then we would have just see the practical side so that we can see all these stuffs. Spark combines a number of functionality of tools available as part of Hadoop ecosystem. So you can use Spark for lots of things, like the machine learning, the SQL-like operators, the graph, batch processing, and lots. This allows for various tasks to be completed on the same platform and make collaborations or functional simpler for programmers, data engineer, and data scientists. So now this is talking to Spark as an application. But if you understand that the the real thing behind Spark is the technology of in-memory. Okay. So Spark includes many purpose-built components. The Spark core, the Spark SQL. So on Spark, you can run your normal SQL, Spark streaming. So you see, so guys that chose Spark for streaming. So I will say, okay, you guys are correct. Though the answer I was expecting was Flow. So Spark streaming, it's a part of component in the Spark application. Though Spark is not seen as application. So that's why you don't see it as application for the Hadoop ecosystem, because it's already sitting, it's only optimizing the other applications. So we have Spark for SQL, streaming, graphics, and machine learning library. So that's the M library. Okay, Spark core. So this is a basic component of which the other component depends. That's the Spark core. I think I saw something here. I see Spark core programming. So it is application at which every other application depends. The Spark core includes basic functionality needs for task scheduling, memory management, fault recovery, interacting with storage system, and running jobs. All of these functionalities on their own, they are dedicated tasks. Like task scheduling, it's a dedicated task. Memory management, it's a dedicated job. Fault recovery, so we understand the fault recovery architecture of replicating data block, interacting with storage system, and that is communicating with the Hadoop distributed file system and running jobs. So, and as required by other components, key among these is the RDD, resilient distributed data set concept, which is the main element of Spark API. This includes a collection of items distributed across many compute nodes that can be manipulated in parallel. So parallel computing, in-memory computing, those are the background technology for Spark. Spark Core offers a way of sharing information between computing nodes with brokers variable and accumulators. Spark Core also includes other core functions such as networking, security, and data shuffling. I wish I can explain deeper, but just keep in mind what the functionality for Spark Core. We can read up and so as to understand how these guys work. Spark SQL, you should understand that it's going to be used to query distributed table. So with the Spark SQL, you can connect to your Hive and you query your data set. The Spark SQL offer a query optimization framework called Catalyst, which can be extended by custom optimization rules, as well as includes of thrift servers, which can be used for external systems such as BI tools to query data through Spark, SQL using classic Java database cluster and ODBC. So Spark SQL, the major function is optimizing framework. So when you run those queries, even when you run queries, SQL queries on Spark, it optimizes the process and make sure you get your data out very fast. So also we have Spark streaming. This is a framework that enables processing of real-time streaming from multiple sources, such as HDFS, Kafka, Flume, Twitter, another and other custom sources. So all these guys are okay. Here, see Flume. So that's what I'm saying. The real streaming, based on our material, Flume is a streaming application which Spark sits on it to optimize the process. So have any one of us, have you heard of Kafka before? Hello? Have you heard of Kafka? I know we've heard of Twitter. Have you heard of Kafka? So Kafka is also a data warehouse system. I think WhatsApp is using Kafka, not Hadoop. So it's also a streaming, any application that deals with streaming information, like a lot of information are moving from one end to another. They use Kafka. Kafka is a streaming data warehouse, or probably streaming file system. The Spark streaming API for data stream closely resembles the Spark core RDG API, thus making it simpler for developers to learn the project quickly. So that's that. One other thing we need to understand is that of Spark graphics. So these are data structure comprised of vertices and edges. Connecting them are known as graphs. So Spark graphics. So in this application, it's mainly used for guys that are doing all these geo-coordinate referencing. So they will make use of Spark graphics. So when you are all these Google APIs, they are making use of Spark graphics. Google API for locations, all these locations, analytics, and probably map and georeferencing. So we have Spark MLIB, so that's the machine learning library. So whereby you can do a lot of your machine learning on the fly. You all possible, at least all normal algorithms. Though you can install more algorithms, but you have basic algorithms like you do your regression analysis and your support vector machine, decision tree, random forest, and the likes. So that's that. Please, you can read up these guys on sorry. So the following system, Hadoop ecosystem, you see, we have we've talked about OZ, HBase, Zookeeper, Scoop, Flume, Chukwa. I've not seen this guy before. Chukwa, Storm. I know of Graph, Pig, Hive, Alt, Drill, Impala, Ambari. So these are Hadoop ecosystem. The Hadoop world is wide, is very big, very big. So, but it's good we familiarize ourselves with it so that we know they exist. Okay. If you compare the previous figure with Spark, okay, Apache Storm can be replaced with Spark streaming. Apache Graph can be replaced with Spark graphics. So those are they're just trying to tell us other applications that we can use instead of the Spark family. So on the Spark family, we know we have the Spark for the Spark MLIB, the Spark graphics, the Spark streaming. So on each of them, we have their corresponding Apache application that we can use to replace them. But when you know how to use Spark, you'll be familiar with, you'll be able to work with different functionalities within the Spark family. Okay, so Apache Pig and Apache Scoop are not applicable in Spark framework as their functionalities are included in Apache Core and Apache SQL. So that is logically correct. So however, you can still run Pig on Spark. Okay, so please let's keep all this in mind. Keep them, we just need to get ourselves familiar with them. So that we know they exist. Okay. So understanding one other thing that Spark is also not required to run on YARN. Apache Mesos and Apache standalone cluster are alternative cluster manager for Spark. Please, I can't deep dive enough into Spark in one class, but please, I will advise us we go and read. Just get yourself familiarized with it, because all these applications, they are applications that, especially for data engineer, so that it can take you a full month course to understudy Spark alone. So understanding Spark alone can take you a full month course. So, but these guys, that's how brought it into the curriculum so that at least we can understand their basic fundamental. So that in this course is just fundamental. It's still the fundamental part. In next class, we'll be talking about the Spark programming. Okay. So installing Scala. Scala is classified in Java virtual machine language as it uses the JVM executive rule. So you would do a hands-on on this in our practical class where we are going to install Scala and see how we install different packages like the normal import Java utility and the likes. Okay, so understanding data type that Scala supports, like the normal data type that we always see, like the byte, the character, the short, the integer, the long character, the float, the double, and the boolean. So these are classes, and that Scala doesn't support primitive data type like Java. Since they are classes, you can use class method to manipulate them as in Java. So that is that. We'll get to understand this more in our practical class, and especially when we get to the programming aspect. So on this note, you can read up on the basic functionalities of Scala to understand how it works, and we've talked about Spark, understand how Scala works, how do we get it installed, and how do we make use of it. So do we have any question?
Hello, sir.
Hello?
Hello, sir. Can you hear me?
Yes, I can.
Okay, I want to ask about the Spark that we mentioned earlier. We already established that it doesn't run on, or it doesn't rely on MapReduce. So I want to understand which the framework it runs on, because we already established earlier that yarn and MapReduce are the frameworks um, for running on the Hadoop ecosystem. So if it doesn't run on, or if it doesn't rely on MapReduce, then what does it run on, or what does it rely on then?
Okay, so that's fine and beautiful. So if we understand what makes MapReduce is ability to distribute itself. So when you have the ability for the application, when you write a job, so that we write MapReduce in Java. So the major thing Spark is working on is that Spark is trying to get the job done without MapReduce. So what is happening is that the architecture of MapReduce is that when you get a job, you have the ability to distribute the job in parallel. Spark now came up and said, see, I want to work on MapReduce architecture. I will also run in parallel, and I will also distribute myself without working on MapReduce architecture. So, but they still serve the same function: ability to distribute itself, and ability to run in parallel across nodes, and ability to tolerate fault tolerance. So we know that the three attributes of a MapReduce job is: we talk about parallel execution, we talk about distributed system, and we talk about fault tolerance. So any application that can run on those three methodology can bypass MapReduce, because MapReduce is just aggregating all the three features. So Spark is now saying, I'm going to create my own. So far I'm working in memory. I have the ability to distribute myself, and I have the ability to run in parallel. So there's another thing that we showed, that how to see that it even did not depend on yarn. So it has its own resource manager. I want to see.
So it's the last page.
Last page, okay. Thank you. So on the other hand, Spark standalone cluster manager. Oh, I'm coming. Okay, Spark is also not required to run on yarn. So if we believe that Hadoop, the main component are Hadoop, the file system, MapReduce, and yarn, and Spark is coming and say, see, I want to bypass them. I want to create my own technology, and it's still going to do the same thing. It's still going to have the ability to distribute itself. It's going to have the ability to run in parallel. Then that's fine. So if it can bypass MapReduce, then see it here. Not required. He said Apache Mesos and Spark standalone cluster are alternative cluster manager for Spark. So there's another cluster manager that Spark creates on its own to help it manage its processes, not working with yeah. So that's that. So have I answered the question?
Yes, sir. That's fine.
So thank you everyone. We'll try and keep pushing. And please, I know sincerely, please and please, let us all keep pushing. Let's keep grinding this knowledge. I know it looks so wow. But please, don't give up. Keep pushing do little research that you can, read little of your notes, and be open your mind, and we're sure very soon we'll get to a solid ground. So thank you very much for your time.
Hello, sir.
Yes.
Sir, I would like to ask when next we'll be having practice because I'm having little challenges with mine and really giving me concern. So I was hoping when next so that we could I could relate the challenges I'm facing with probably you or Mr. Temilola, then we find ways to go about it.
Okay. So we're meeting that's Friday. Maybe Friday and Monday. This week Friday and next week Monday.
Okay, sir. Okay, sir. Thank you very much.
You are highly welcome. So thank you everyone. Enjoy the rest of your day.